Hi everyone, my name is Nissan Gabay, and I'm here to talk with you a little bit about testing, specifically production testing, how to do it, why we in Wix chose to do it, and share with you a little bit of the problems and challenges that we found during our adventure to use as many production testing as we can in our systems. So a bit about me. As I said, my name is Nissan. I'm 34 years old, proud father for those two little four-legged girls in the picture. I'm writing bugs since 2003, also trying to fix them, not always succeeding. I'm in Wix for the last year and a half as a team leader of three very skilled engineers that are trying to take over the world, or at least to make our users, the developers around Wix, their builds a little bit greener. And by the way, we have to all the way from sunny Beersheba in our site on the south. I'm part of the Wix DevTools group that, as Itai said earlier, is responsible on giving our users, and when I say users all through the lecture, I mean the developers around Wix, mostly the front-end developers, but also servers, a little bit of QA, etc., to give them as many tools as we can to make their life easy as much as possible, to allow them to avoid writing infrastructure code and giving them the option to focus only on their business logic and do not need to rewrite things that most likely, let's say, that the person and developers on the team on the other side of the door already developed. So let's start with tests. I hope that if you're here, you understand that tests are important. And when I'm saying test, I mean automatic tests that are running as part of your CI build. So on each feature that you are writing, on each PR, tests will be run automatically and allow you to check that everything is going as you expected and nothing was broken. Because you have all those tests, you have a lot of confidence in making changes in your code, because you know that if you break something, someone will already monitor and alert you on it. Second, it will allow you to have a lot more velocity while developing your code, because you don't need to do the regression testing on each line of code that you're writing, because someone is already doing it for you, the tests. And most importantly, it allows you to distribute the work and allows several people to work on the same code base at the same time, because I don't need to know what exactly the developer next to me wrote. I don't need to understand every little bit and every byte of code, because if each one of us is writing tests for his codes, at the end, the integration of everything will combine into one all coverage for the entire system. So what kind of tests do we have? This slide is pretty known, and you also already seen it in the past. We were talking about four kinds of tests. Unit tests are being at the bottom of this pyramid because most of the time we have this is the most common test we have in the system. Unit tests, for those, just to be clear and be on the same page, unit tests are the test for one specific function or class, something very contained inside itself. On the next level, we have integration tests. Tests that are testing my system as a whole, but all the other things outside my system, or other subsystems inside my organization, are not being tested, only as an API test, something really mocked, let's say, but we'll talk about it in a second. Next, we have system tests. This is the testing of my entire organization. All the services are supposed to talk with each other, fine. But it's still happening in isolated environments. It's happening on dedicated test servers, not on something out there at the wild, the internet. For that, we have the production test on the top of the pyramid, testing in the real internet, in the real world, and being affected by real problems like network issues, security configuration and policy of the organization, things that are not related to my code, like AWS decided to break down all of a sudden, and many other problems. And because those tests are so hard to write, most of the time we have those kind of tests are the least in my organization, my project, and that's pretty bad, and we want to change this thing. So if we'll take this entire pyramid and try to look at it at a different angle, not as many tests as we have in the system, but how much I can rely on those tests, how reliable those tests are for me, then we'll see that the production testing are the most reliable that we have, because nothing is being mocked, everything is being tested on real life. We see the things, we're seeing the things as the users are seeing it, and it's the best we can have. While the unit tests, everything is mocked. Every little change that we are doing on a different system might affect me, and I will not know it unless I have a really good typing system, like TypeScript, that is guarding me, but also then we still can have problems. So when I'm saying production testing, what do I mean, how do we do it? So me as a user that are using the internet, I'm going into some kind of website. In this website, in the past, we'll get a huge JavaScript file with all the components, with all the small applications that we have in my system, combined into one big file. But today, when we are living in the world of micro front-end applications, we're not getting one files. Each of them is representing a different part of my system, a different feature or component, and then together the hosting page know how to build everything together and use them. So when I'm doing the production testing, I want to take only one of those applications. I don't want to change everything. In this specific case, in this example, I want to take only application number 3 and change it. So I will not test the production code. I'll test my own code. So what we are doing is creating some kind of interceptors that catch the request and responding back to the user, not the original code, as I said, but a tested version from my deploy preview, which is a different CDN, a different server, whatever I want to see. In that way, I can see how application 1, 2, and the new code of 3 will interact with each other, and if my page is still working as I expect, or something broke in the middle. Question about that? Great. So, testing in production are important. I hope you understand it by now, because as I said before, it gives you a real feel how the user will see the system, how what you will see here is what the user will actually get, and not some kind of mocked or something that might be affected from outside. We are testing the entire system, not just one module, but as I said, how my module is interacting with other ones. It helped me to identify deployment problems, because if I need to actually work on a real server, I need to deploy it first, not on a mocked one in a contained area. And I don't need to handle any mocks at all, because every time something changes, the entire production will change, and then my test will change with it. But when I'm doing it, it also might be scary to do the production testing, because first of all, because I'm testing on real production servers, it will create a lot of load on them, depending on the amount of tests you have, of course. That might be translated into a lot of money, increase in cost, but we will talk about it a little bit later in the lecture. Next, the test can fail due to problems that are not related to me. As I said, AWS decided to break down some network requests, the security policy decided that this test is DDoSing those my production servers and start to drop them down. All those cases are based on real cases that we saw during the last year. So I didn't change anything in the code that might affect it, but still my test failed, which is kind of problematic. Next, because I'm working on real servers and real data, if I wrote some kind of buggy code, it might destroy or corrupt my database. If you want to recover from that, you need to start having a migration, start fixing your test, which is kind of messy. And the biggest problem, and the reason why most of the people are not going to this production testing as a default kind of test, is because it's really complicated to create those things, to create an initial setup in order to test those things in your system. As I said, you need some kind of interceptor that's run in the middle to catch the request, to restore, to give you the code. How do I handle all those things inside of the CIs? How do I make it so it will not take a lot of time, really lots of problems, and we need to handle it somehow. So our flow, what we want to show you today, is how we're taking all the things that I talked about to take all the benefits that we are getting from the production testing, try to overcome all the errors and all the scary parts, and make the production testing the most common test in our code base. Full disclosure, we're not there yet, but we have a lot of tests. In a second, I'll show you how many tests. So our solution is called Sled. Sled is a CLI tool developed by my team that helps the users, again, user Wix developer, to run its TUI test. We'll show you in a few minutes the demo. You'll see that we are running Jest and Puppeteer, two pretty common tools. We'll show them in a second. In a real time, in real production environments, with a great degree of parallelism, which allow you to run a lot of tests in really small time. So it's part of our CI flow without any problem. It's not taking our builds hours, but a few minutes. And the nice part is with almost zero configuration from the user. So it do not need to handle any time, to waste any time on writing the infrastructure, but just write the codes. So when I say that we are running a lot of tests, let's see a bit of numbers. Those are the numbers from the last weeks. So we have 1.5 million tests per day on average. We have a little bit more than 28,000 unique tests around weeks, separated on 627 applications. Some teams have several applications inside of them, but actually we have a lot more applications, somewhere around 1,600, as I said, just from the last week. And for those of you that know a little bit about Wix, Wix loves data, and also we want to collect as many data as we can. Around 7 million of records are being collected each day only on our test. Why we are doing it? Great question. We'll show it a bit later. Spoiler, it will help us to make our service and our solution a little bit better. But a lot of talking, let's see some codes. So I have this page, a really complicated application. As you can see, it has a hello world and some timer that runs. If I'll have a look under the hood, you'll see that the HTML, just a second, a real complicated HTML file that dynamically import the JavaScript. And this JavaScript also, very complicated one. Just change the title to hello world, adding some logs, changing the time, and that's about it. One day, my product manager arrived to me and said, please change something. I want this code to be a little bit different. I want to change it from hello world to hello world from Wix, add some logs, do whatever changes I want in the site, and this is the new feature. Now, I want to run all my tests to see if this new code changed something, if it broke something off my test, to see what happened in my system. So all I need to do is just run my test. I'll run it right now. Also, I had some problems with my VPN earlier, so I hope nothing will break right now. If no, we have a backup. What's happened as we speak? So we have 100 tests. All of those tests are exactly the same. They're running on Jest. As I said, Jest is a tool from Facebook that helps us to run tests, mostly for unit tests, but you can do it for whatever you want with it. And we are using Puppeteer, an open source tool that allows you to communicate with Chrome and just handle your test through it. So things like go to page X, select button Y, etc. All the pages are exactly the same as I said. We're opening a new page, going into example.com, waiting for 3 seconds, taking a print screen, and comparing this screenshot with the screenshot that we have on the system, on our database from before. We have so all of those tests are the same, except one test that are going to the page that actually check what the feature that I just changed. So I ran 100 tests. Each of them take around 3 seconds, as I said, because I had this lovely sleep. Imagine that this sleep represents some action that you're doing during the flow. So from simple math, if you're taking 100 tests, multiply it by 3 seconds, you're supposed to have 300 seconds per all this suit, which means around 5 minutes. But as you've seen, it only took me 27 seconds to run. The reason because it's happening is because we are running all those tests parallelly on the cloud and AWS, but more on that in a second. And we can see that almost all of my tests passed, except one, the one that actually checked my feature. So, so now that I have my result, I need to have some ability to dig in to understand what went wrong in my test. So we created this dashboard. I'll explain a little bit about it a bit later, but as you can see, it shows you a lot of things and a lot of information about what happened in your test. Things like the console logs inside your page, all the network requests. Just a second, text. everything that we got. And you can also see why the test failed. In this specific case, the test failed because the image was changed. That was my baseline, just hello world with some kind of date. And the new solution, the new feature that changed the from weeks. I see that they also have another thing that I didn't expect to change. That's the time that it shows, the current time. And that's a problem, because every time that I will enter this page, every time that I'll run this test, I'll get a different time. So I need to have some way to ignore a specific area in the test, a specific area that I don't want to test it. So for that, we created another dashboard, another tool. We'll call it Sheshesh, as the visual thing, because that helps us to track and do all our visual comparison. And from that, I can also edit mask and decide that this specific area, the area of the timestamp, will be ignored. So from now on, in the next test, it will not be shown and will not be tested, only the area that changed for the label. Question so far?
What happens if your system has some kind of payment module? How do you test that?
What exactly the question? What's the question about the payment module? He asked about payment module, but what exactly happened there?
Yeah, so if you testing some kind of production, right, and your system has a payment module, can you do without any mockups?
Okay, so we asked about mocking a payment module, and not just payment. I guess it will happen for all the real third-party applications and things that we want to check. Most of those vendors have some kind of testing account or testing client that you can use. So we're
Like Sandbox?
Yes, Sandbox. So we're using that. We also have those kind of payment. We also have it for Twilio, if you know it. They're providing us a virtual number that we can using it to contact our users. There are several ways to use it. So we are still in production area. You don't need to mock anything, but that's depending on the third party and which test kit and toolkit it provided us. So how we are doing all those magics. So let's talk a bit about history and why did we decide to go to do it. So in the beginning, there was a little tool that developed by one of Wix users that helped to run those tests, helped to do all the connection to the new deploy previous service, etc. But it ran on your local machine or the CI machine, which took a lot of time because some people saw it was good. They started to write a lot of tests, and then each build took about an hour and even more. That's not something that we can live with it because we want our life to be as fast as possible. We don't want, as developers, to go to start a build and go play ping pong or something a lot of the time. It's just not for that they are paying us. So we decided to go to the cloud and do there on all the jobs. How we do it? The CLI that I just showed you, starting its work, it takes all the tests and bundle it and all the configuration that it needs and send it into the server. The server is not one server, but a complete architecture of servers are called serverless at the AWS framework, for those of you that know it. We are using Lambdas. Lambdas are small servers. They are not exactly servers, but they are the option to run just one specific function, specific code. It spin it up, use it, call whatever it needs, do whatever logic it needs, and then die. No need to handle special logic with creating new instances, handling the autoscale, etc. So we are calling this orchestrator Lambda. This orchestrator, by the way, is not one Lambda. It's several Lambdas of doing a lot of work. But the important part is that orchestrator is calling lots of small Lambdas. Each one of those Lambda is running its own test, its own spec file separately. And then when all of them are finished their work, they just put the result back to some kind of bucket, an S3 bucket. And once everything is done, we are taking all the result, we are combining it into one just result, one thing that have all the information that we need, and we are returning this result back to the CLI. The CLIs know how to interpret this result and decide if the build passed or failed on its own. But not everything is green and happy. And we have a new solution, and just a second. Okay. We have a new solution, but we also have a new problems or new challenges that we need to tackle. So I want to share some of them, and if some of you will decide that you want to test and do production testing in your company, keep those in mind and figure out if they worth the hassle. So the first thing is, because we have a lot of tests, and a lot of tests are running simultaneously in weird ways, because we are working by PR, so we have a peaks of load, and not something that is happening all the time and persistent. So we need to handle it some way. By the way, at some point at the time, 30% of the traffic arrived from tests, which is crazy. Just think about how many servers you need to create and spin up just to support your tests. And on the cost, it will affect your system. So how we handle it? We decided to create some sort of cache mechanism, but a special kind of cache, not cache only for this specific Lambda, but a cache that will be distributed around several Lambdas. Before all the tests are starting, we are running just one recorder Lambda. It's doing some sort of logic, whatever you decide as the developer to do. And now we are recording all the network requests. In the next Lambda that will be running, and it can be thousands of Lambdas, we are using the request from the network request from this cache, and not calling the actual servers. By doing that, we are reducing the amount of requests that are going to our servers, because we just don't need it. We already have the response. But that's if we are taking into account that all requests will return exactly the same response every time, and nothing will change. So it's very good for GET requests, but not for POST or something that changes the site. Second, we introduced a new concurrency limiting flow around the system. So I can decide that Artifact X have a really strong server, or it can handle a lot of requests, so we don't need to put any limitation. But other server, I can limit it to run only 100 tests, let's say, or whatever I want to limit. And this limit will be cross PRs, and not just for my PRs. That's the smart thing here. So several people can still work and not worry that they are corrupting or causing any harm to production. Next, as I said earlier, we are running in real environment, real issues that might occur that are not related to me, and those things can cause the test to be flaky. So we need to handle it somehow and cause the test to be as green as possible and not being considered by real code, by real environment issues. So the way we did it is to run each test 3 times and not just 1 time. Because all the tests are running parallelly, it does not waste a lot of time on our side. So why not? Let's just run it 3 times. If it passed at least 2 out of those 3 times, we're considering this test as good enough, and we can let the user continue its work. If at least 2 failed, then there must be some problem with the test itself, then we're failing the entire flow. Except from that, we created several retry mechanisms that are based on the result that each test got. And by that, we can see if the result is actually due to a problem of the test or something in the network, and by that decide which kind of retry we want to do, maybe give a little more memory to the test to make it faster, and some other considerations. Next, we are running a lot of tests. The cost is high. How high, you are asking? A lot. Somewhere around last December, we had around, like I said, let's say it will be 6-figure numbers only for running tests, just for 1 month. Multiply it by 1 year, tons of money, and we want to reduce it to the minimum as we can. So, if you remember earlier that I said that we are collecting information, we are collecting a lot of information. Some of this information will be if the test was successful or not, how much memory we allocated per Lambda, how much memory the Lambda actually used. The reason that I'm saying it is because AWS are calculating the account by the amount of time that the Lambda ran multiply it by the amount of memory that you allocated in the Lambda. It doesn't matter how much memory you used, but only how much you allocated. And by that, deciding the Lambda will cost you X dollars. So by taking this, all the information that we gather, we can decide how we want to distribute our test, and maybe doing it a little bit smarter. For example, if you remember I showed you a second ago that we run each test 3 times, but if we see that the test is really, really stable, and I mean it passed for the last, let's say, 95% of the times, there's no reason to rerun it for 3 times. One will be enough, and then just retry it if it will fail for this 5% of the time, which causes us to run significantly less tests and still get pretty good results about what's going on. Another flow that we created is changing the size of the Lambda. At the beginning, we allocated for each Lambda 3 GB of memory because Chrome is a little bit greedy on its memory, and it's using a lot of it. But it was needed only for some of the tests, not all of them. There are lots of tests that you are using much less, let's say a gigabyte or a gigabyte and a half. So why should I allocate so much memory and waste so much money when I can use much less? So again, we go to the BI, we saw how much memory each test used in the history, and then we gave it the amount that it needs, and not the amount that we actually can give it. And by doing so, we managed to reduce our costs from, as I said, 6 figures to about a third of it. And last but not least, because we are a team of only 4 people, we can support all the tests and can support all the developers on what they did on their tests. We need to give them a lot of tools to help themselves to figure out what went wrong in their test if there was some kind of problem. And we have several tools that we developed only for that specific goal. The first one is our dashboard that I just showed you. This dashboard should represent everything that was happening in your test. The network request, all the logs, if it was the issue, what was the issue, why it happened. We are printing every few milliseconds the test, so you can also see some kind of a video of what happened in this test during this time. Hopefully it will give the user the ability and the tools that he needs to investigate what happened. But if he didn't manage to get it from that, we also created some sort of debugger. This debugger is allowing the user from his own machine to debug some kind of, debug a Lambda that is running remotely somewhere at AWS. We are opening a port, some kind of proxy server in the middle, and then from my own machine, I can see on the top side the code, the test itself, on the bottom side, the Chrome that is being opened as part of the test, and just seeing what went in each and every step. But debugging the test and figuring out is not the only thing that we can give the users. We also want to increase their awareness to their tests and which tests are bad and need to have their immediate attention. So each week we are sending a Slack message to all the teams about their 5 worst tests they have, things that need to get their attention right now in order not to fail their test. That proved a lot of help, and the amount of flaky tests that we have in the system are being reduced dramatically. But that's not all. We also created some sort of, for those of you that have been in our previous lecture about the CI police, we created the rules that allow you to figure out how many tests you have, bad tests you have in the system, and don't allow your red, even if nothing ran, just by saying you have flaky tests. Just first fix them and then run your tests so you don't waste time or money. So, a quick recap for what we had today. I hope that I show you that production testing is hard but worth it, because you're actually seeing what your system will look like before you're deploying it, and all your problems will be hopefully fixed before it. If you want to have a good coverage on the test, you need to make your test writing as easy as possible to give the users a lot of tools just to write their tests. And most importantly, make those tests run fast, because fast test is equal to fast development, and that's what you want as a developer and as an infrastructure developer for your users. Thank you for your time, and if someone has any questions.